Hello everyone, let's do a simple problem based on mesh analysis. Okay, so first we would begin this session with a simple circuit with, okay, and this is a DC circuit because all the passive elements are all resistors over here. So all the voltages and current inside the circuit will become constant. They are all DC voltages and DC currents, right? All of them are constant. So in this circuit there are three meshes, and here, so for each mesh I'm going to mark I1, I2 and I3, and all of them are marked in the same direction, clockwise direction. Okay, so one thing about this mesh analysis is that since I have marked I1, I2 and I3 in this way, so now I can tell the name of the current in each and every branch, right? For example, the current through this branch is I1, and according to your assumed direction it flows from left to right. Okay, so that is one, and this is the current through this 2 ohm resistor is I2, the current through this resistor is I3, right? Through this 10 ohm resistor is I3, the current generated by this 10 volt is I1, the current through this branch, through this voltage source is I3, right? The current through this branch is I2, right? And the current through this branch is I1 minus I2, right? Because there is a current flowing downwards I1, and there's also another current flowing upwards, that is I2. Therefore these two current are negating each other, right? Negating each other, or cancelling each other. So therefore it will be I1 minus I2. Over here also there's a current in this branch, there's a current I2 flowing downwards, and there's current I3 flowing upwards. Therefore the current through this resistor is I2 minus I3. Okay. Oh, and one more thing also, your answer, so sometimes even if you have assumed the direction should be from left to right or from top to bottom, sometimes in reality it may be different. So how do you understand this? That only thing difference is that you'll get a minus sign in front of your answer. If you get a negative sign in front of your answer, then it means that the actual direction is different from the one that you have assumed. Alright. For example, here you have assumed that here this is I1, and according to your assumed correct direction, it flows from left to right, right? Clockwise. So this I1 is flowing from left to right. But even if so, suppose if you get the value of I1 as, for example, I1 is equal to minus 0.5 amperes. So what does it mean? It means that the direction of I1 is opposite to the one you have assumed. That means in this branch, even if you have assumed it's left to right, in reality it is from right to left. So that's the only difference, right? The direction will be opposite, or there will be or the sign will be opposite. Over here also, even if sometimes it can be I1 minus I2. If it is I1 minus I2, the direction will be downwards in this branch. If it is I2 minus I1, then the direction will be upwards because I2 is greater, right? So it will be upwards. So that's how we usually understand the direction of the current. But the actual value will be correct. The answer will be correct. Only there will be a change in the sign. Okay. So let me write the equation. So first I'll start this problem by writing the equation of mesh 1. Okay. So equation for mesh 1. Equation for mesh 1. So here I'm going to assume, so here in this mesh 1, since you see I have marked each and every current in the same direction, clockwise direction. Why? The reason is because if you mark it in the same direction, then whichever current you are writing, for whichever mesh you are writing, that current will be positive. Whichever mesh you are writing, that corresponding current will be positive, and the rest of the currents will be negative. So since in this mesh 1 there are two currents flowing in this mesh, that is, one is I1 and the other one is I2. In this branch I2 is there, right? So therefore there are two currents, I1 and I2. Therefore since this is mesh 1, I1 is considered positive and I2 is considered as negative. And now I'm not going to write this equation in terms of its resistors or anything. I'm just simply going to write the final equation. You should learn to write like that. Learn to write the final equation. So how do I write this? First I will see the whichever resistors or whichever elements this current touches. So this current touches, right? It goes like this, right? So with this current touches this 6 ohm resistor and this 1 ohm resistor, right? So therefore 6 plus 1, 7. Therefore the coefficient of I1 is 7. 7 I1. See, that's how I got 7 because it touches these two resistors. All right. and this is mesh 1, so therefore I1 is positive and there's I2 current and that I2 is negative, so it will be minus. All right, minus, and this I2 current touches only this 1 ohm resistor over here, right? So therefore 1 into I2, so 7I1 minus I2 is equal to, now I am going to write the equation for the voltage sources. And here there is only one voltage source and that is 10 volt. So should it be plus 10 or should it be minus 10? You should understand that. For that, just simply look at the positive terminal of the battery. Alright, we know that for a battery or for any voltage source, right, this voltage source will be generating current from the positive terminal, right? It generates the current from the positive terminal, right? That's how all the batteries or voltage source works, right? It generates a current from the voltage from the positive terminal and it enters into the negative terminal. Now look over here in this I1, the direction of I1 is in the clockwise. Therefore in this branch the direction of current is like this, right? It's flowing from bottom to top. That means this positive terminal is actually generating I1, or this positive terminal is actually supporting the generation of I1. Therefore this 10 voltage is positive. So 7I1 minus I2. This is the equation for mesh 1. Okay. Likewise, the equation for mesh 2 is, so since this is equation for mesh 2, I2 is positive and I1 and I3 are considered as negative, right? There are three currents that's flowing this mesh 2, right? Here in this branch there's I1, here in this branch there's I3, and the branch of and the current I2 is flowing through all the resistors, right? So that means in mesh 2 the I1 is touching this 1 ohm resistor, so it will become minus I1, okay? And I2 is positive, so plus, and I2 touches 1 ohm, 2 ohm, 3 ohm. 1 plus 2, 3, 3 plus 3, 6. So it will be plus 6 I2, okay? And then I3 is also negative and its coefficient is touching only this 3 ohm resistor, so it will become minus 3 I3, okay? This is equal to, there is no voltage source, so this is equal to 0. This is the Kirchhoff's voltage law of mesh 2. Okay, now equation for mesh 3, right? Equation for mesh 3. So here, according to mesh 3, there's no I1 in the circuit, right? And there's I2 and I2 is flowing in this branch. So since this is mesh 3, I3 is positive and remaining currents are considered as negative. So I3 is positive. So I2 is current I2 is flowing over here, right? And that is, so it is touching this 3 ohm resistor, so it will become minus 3 I2 plus, and I3 is touching these two resistors, right? I3, so it will become 3 plus 10, which is 13 I3 is equal to, now there is a voltage source over here and this current I3 is entering into the positive terminal, right? That means this positive terminal is not generating any current. This positive terminal is not producing any current. It's opposing the flow of current because this I3 is going inside into the positive terminal. So therefore it will become minus 20. Okay. So this is the Kirchhoff's voltage law of mesh 3, right? So now the next step what you do is we are going to write the matrix form of these three equations, okay? Writing the above equations in matrix form, okay? So there are three equations, so therefore there will be 3 rows, right? And in the first row, the coefficient of I1 is 7, the coefficient of I2 is minus 1, and the coefficient of I3 is 0. There is no I3 over here, therefore the coefficient of I3 is 0. So in the first row, the coefficient will become 7 minus 1, 0, okay? In the second row, the coefficient of I1 is minus 1, the coefficient of I2 is 6, and the coefficient of I3 is minus 3. So it becomes minus 1, 6, minus 3. Okay. And in the third row, the coefficient, or in the third equation, the coefficient of I1 is 0. There is no I1 over here. Right? So the coefficient of I1 is 0, the coefficient of I2 is minus 3, and the coefficient of I3 is 13. So it will become 0, minus 3, 13. This is the coefficient matrix. And your unknown variables are I1, I2, I3 is equal to, and the equation and the matrix of your voltage source is 10, 0, minus 20. 10, 0, minus 20. This is the matrix form. Alright. So now what you're going to do is you're going to find the value of I1, I2 and I3. So first I will find the value of I1. So to find the value of I1 is nothing but the determinant of the matrix in which the first column must be replaced with the voltage source matrix. So it means it will become 10, 0, minus 20, and the remaining columns will be same. Minus 1, 6, minus 3, 0, minus 3, 13. Determinant of this matrix divided by determinant of the coefficient matrix, that is 7, minus 1, 0, minus 1, 6, minus 3, 0, minus 3, 13. Okay. The determinant of the denominator will be the same for all the currents, right? So you just need to find this value, the denominator only one time, and then substitute that for all other currents, right? But this will be different. The numerator will be different for all the currents, right? So what is the value of the numerator? 10 into, okay, 6 into 13 is 78, right? 78, and this is 9, so it will become minus 9. Minus 9, okay. Minus of minus is plus 1 into 0 into 13 is 0, and this will become 6, so it will become minus 6, right? It's not minus 20, it's minus 20 over here. Okay, it's minus 20, all right. So it will become minus 60. Minus 60, okay. And here there is no, and 0 into, so there is no use of finding the value over here. So therefore, this is the numerator, okay. And for your denominator, let me see, it will become, over here it is 7 into, and here you have 6 into 13, 78. This is minus 9, okay, plus 1 into, minus of minus is plus 1 into, and here you have minus 13, right? Minus 13. So here you have minus 13. So this is the value you'll get. So therefore I1 is, let me see, I1 is equal to, let me see, I1 is 78 minus 9 is 69, I think, I believe, right? 69. So it will become 69, so it will be 690 minus 60 by, and over here it will, here also it will become 69, right? So it will become 7 into 69 minus 13, okay. So which means, let me see, so numerator it will become 630 by, and the denominator is, let me check, it will become 7 into 69, 7 into 69 minus 13, 470. So it is over here, it is 470. So you will get the equation for the current will become, so 630 by 470. So 630 divided by 470. 630 divided by 470 is equal to 1.34. So the answer of this is I1 is 1.34 amperes. Okay. So I found the value of current I1 as 1.34 amperes. Next I'm going to find the value of I2. So I2, so to find the value of I2, we will check the second column must be replaced with your voltage source, and the remaining column is the same, which means the first column is 7 minus 1 0, 7 minus 1 0. The second column is 10 0 minus 20. 10, 0, minus 20. The third column will be the same. 0 minus 3, 30. 0 minus 3, 13. Okay. Divided by, and the denominator will be exactly the same. 7 minus 1, 0, followed by minus 1, 6 minus 3, minus 1, 6 minus 3, and the third column will be 0 minus 3, 13. 0 minus 3, 13. Okay, so this is equal to, so let me see now. So here you have 7 into, okay, this is 60, so it will become minus 60, right, minus 10 into, right, minus 10 into, and this is minus 13, minus 13, minus 0, so minus 10, minus 13. Let me check if it is correct. Okay, so it's correct, right? I hope it is correct, right? Let me see. Yeah, okay. So now, and the denominator you don't have to find again. You already found the value of the denominator is 470, right? So no need to find the value again, right? So that you get this answer. So this is nothing but, let me see, minus 420 plus, minus 420 plus, this is 130, right? 130 by 470. By 470. So which means you will get the answer as, let me say, so which means this is nothing but minus 420 plus 130 divided by 470, right? Divided by 470. So you will get minus 0.617 amperes, minus 0.617 amperes. Okay, right. Next is I3. So next I'll find the value of I3. Now to find the value of I3, 7 minus 1, 0. The second column also will be the same, minus 1, 6, minus 3, and the third column will be replaced by the voltage source column, 10, 0, minus 20. And the denominator will also be the same. Denominator is 7 minus 1, 0, minus 1, 6, minus 3, 0, minus 3, 13. Okay, and here it will become 7 into, it will become minus 120, minus 120, okay, minus 0, so no need. Then we have plus 1, right, plus 1 into, this is 20, just 20, minus 0, all right. And then we have plus 10 into, plus 10 into, we have 3, just 3, right, just 3 over here. The whole thing is divided by, here the denominator is the same, so again 470. So therefore you will get over here, this is minus 840, minus 840 plus 20 plus 30, right? So we have, and this is divided by 470. So you will get the answer as, this is equal to, let me see, so this is equal to minus 840 plus 20 plus 30 divided by 470. You get minus 1.68, minus 1.68 amperes. Okay, minus 1.68 amperes. So this is the value of the current. Okay, so now we found the value of I1, I2 and I3. So now let's read the question again. Find the current through the 3 ohm resistor. So what is the name of the current that's flowing through the 3 ohm resistor? It is I2 minus I3 or I3 minus I2, whichever it is, because the only difference will be your sign change. It can either be a positive sign or negative sign. That's the only difference. So I'm going to assume it is I2 minus I3. Okay. So find the current through the 3 ohm resistor. The current through the 3 ohm resistor is I2 minus I3. Therefore, I like that. Current through the 3 ohm resistor is equal to I2 minus I3, which is equal to, and what is the value of I2 is minus 0.617, and the value of I3 is minus 1.68. okay, I2 minus I3. So you will have, this is minus 0.617 plus 1.68, right? So this is nothing but equal to, let me see, minus 0.617 plus 1.68, and you will get the answer as 1.063 amperes. 1.063 amperes. This is the current of flowing through 3 ohm resistor. Okay. Suppose if they ask you to find the voltage of across the 3, suppose if they ask you, instead of asking us to find the current through the 3 ohm resistor, they'll ask you to find the voltage across the 3 ohm resistor. So we know, how do you find the voltage across 3 ohm resistor? We know that voltage is equal to current into resistor. So whichever answer you are going to get over here, multiply that with the 3 ohm resistor, multiply that with 3. So you will get the voltage across the 3 ohm resistor. Okay, in case if they ask a question like that. Okay.